Let's look at the final exam review problem in your worksheet. And the first one, we have 8x plus 8 equals 12. Solve for x. So we subtract 8 on both sides. You will have 8x equals 4, then divided by 8. So you have 4 over 8, which means 1/2. Okay? The second one, f of x equals negative x squared minus 4x plus 1. So what is f of 4? F of 4 is you replace x with 4, so negative 4 squared. Okay, so this square is on the 4, not on the negative. Minus 4 times 4 plus 1. So this is a negative 16. Okay, I use the parentheses, means this is the position of x. Okay, minus 16 plus 1. So this would be negative 32 plus 1, which is equal to negative 31. Number 3. Graph the inequalities x plus 4y greater than or equal to 5. Okay, so here is the one way. So you can pick arbitrary 2 points, right, to graph. So the first thing we need to graph this line, the boundary, right, equals 5. So this is the graph. Okay, so we pick when y equals 0, plug in y equals 0, x equals 5, right? So 5, 0 is on the graph. 1, 2, 3, 4, 5. 5, 0 is here, right? If we take x equals 1, y must be 1. So 1, 1 is here. So you connect these 2 points. This is the 1, 1 point, right? This is the 1, 1. So this is 5. So you connect these 2 points. So this is a straight line, is a solid line. But the reason is here is a greater than or equal to, right? So the boundary is included. So greater than 5, greater than or equal to. So which part? We have 2 parts, right? One part is above this line, one part is below this line. So we pick an arbitrary point to test. For example, for our canoe, we always pick this one, the origin. Okay, we pick the origin. Origin is 0, 0 to see if this satisfies. So 0 plus 4 times 0 equals 0, which is greater than or equal to 5? No. So the plane containing the origin is not the 1, so we should take the 1 above this line. Okay, so this is number 4. A steel company produces 2 types of machine dies, part A and part B. Okay, so part A and part B. $3. The profit for the part A is $3. And the profit of part B is $4 or $5. If we let x to be the number of part A and y to be the number of part B, write an objective function that describes the total weekly profit. Okay, the total weekly profit, so objective function. We want to write down the objective function is the profit, total profit. Z equals the profit for part A is $3 each, so total x part A, so you have 3 times x plus 5 times y, right? Okay. The next one, number 5. To make some extra money, you mix 2 types of picture frame, type A and type B. The initial expense is $75. The cost of the type A, so this is the A, this is the B, cost, type A is $3.6. Type B is $5.2. Okay, then the profit, sale price is type A is $6 per frame. The price for type B is $10 per frame. Let X to be the number of type A, is type A frames, and the Y be the number of type B frames. We want to write an inequality describe the revenue is less than the cost. Okay, so the first cost is, what is cost? The total cost is the initial expense, $75, plus the cost for type A, which is 3.6 times X dollars, plus 5.2 times Y dollars for type B. So this is the cost. So the revenue is, the price for type A is $6 per frame. So you have 6 times X plus 10 times Y. So this is the revenue. So it says we want to write an inequality describing revenue less than cost. So 6x plus 10y is less than 75 plus 3.6x plus 5.2y. Okay. Of course, you can continue to simplify. So we subtract 6x on both sides. So you have 10y less than 75 minus 2.4x plus 5.2y, right? Then we subtract 5.2y on both sides. You have 4.8y less than negative 2.4x plus 75, right? Then you divide by 4.8 because 4.8 is a positive number, so you still keep this direction for the inequality. So this would be negative 0.5x plus 15.625. Okay, so this is another one. This is the answer, and this also would be the answer. Okay, it depends on the problem, which form it will ask you to do. Number 6. Crochet beach hats and baby Afghans. Okay, so 2 hours for the hat and Afghan. Okay, so you need 2 hours to produce a hat, to make a hat, and 8 hours. 8 hours make a hat, and 2 hours to make Afghan. And the total only have 16 hours available. Write an inequality to describe this situation. Okay, so if we let x to be represent the numbers of hat and the y be the numbers of Afghan, so the total hours is 8 times x plus 2 times y. She has only 16 hours available, so should be the total hour should be less than equal to 16. Right. So this is the inequality to describe this situation. So the next one is we want to use this inequality to determine whether she can make 9 hats and 8 Afghans. Okay, so now let's look at it. If x equals 9, so the second part is x equals 9 and y equals 8. Will this works for this situation? So we just plug in 8 times 9 plus 2 times 8 should be less than equal to 16. This is 72, and this would be 16 less than equal to 6. So you have 88 less than equal to 6. So this is not true. So the answer is no. Number 7. Benjamin has at most 21 hours free during the week. He is trying to make a weekly plan for dividing his free time between reading and walking. And he wants to spend at least hours per week reading. So write down a system of inequalities to describe this situation. We let x be the numbers of reading, hours of reading. And y represent the number of hours for working out. Okay, so total, so x plus y, so at most he has at most 21 hours free during the week, so it's less than equal to 21. He also wants to spend at least 7 hours for reading, so x should be greater than equal to 7. And then, of course, here we have another requirement. Y should be represented, the number of hours should be greater than equal to 0. So these three inequalities will describe the situation. Now let's look at the next one. Number 8. So we want to graph the inequality y greater than 1. So this is the 1. So first let's locate y equals 1. Y equals, since here is greater than, so the boundary is not, y equals 1 is not increased, so we use the dashed line. So, but which half plane will be this solution set? So obviously it should be above this line, right? We can test any number you want. We can test 1, 0, right? This is 1, 0, right? 1, 0, so that means if you plug in here, there's no x, so y equals 0, so 0 greater than 1? No. So this point, the plane containing this point should not be included. So which means you should use the other half plane, which is above this line. Okay? This is not right. 9. Objective function is z equals 5x plus 8y. Okay, so we want to find the maximum, max and the minimum values for the given region, feasible region. And we know from the linear programming section, and the maximum or the minimum values only happens at the corner of the region, right? So we just need to test the value of the objective function at the corners. So the first corner is 0, 9. So 0, 9, z is equal to 5 times 0 plus 8 times 9. So this is the 72. The second corner is 9, 9. And so z equals 5 times 9 plus 8 times 9. So this would be 117. And the next one is 9, 2. 9, 2, z equals 5 times 9 plus 8 times 2. So this would be 61. And then the next one is 0, 3. 0, 3. So z equals 5 times 0. 3, 0. 3, 0. So 5 times 3 plus 8 times 0, which is 15. So the last corner is 0, 3. So 0, 3. So 5 times 0 plus 8 times 3. So this would be 24. So this would be the maximum value, 117, and this one would be the minimum value, 15. So we just pick the lowest one, the smallest one, the greatest one. 10. The objective function is z equals x plus 5x. We want to find the maximum value of the given feasible region. Okay, so we have 3 corner points, right? We just need to test the values at the corners. So the first corner is 2, 5. 2, 5, so z equals 2 plus 5 times 5, which is 27. And the next one is 4, 2 point. So this would be 4 plus 5 times 2, which is 14. And then the next one is 3, 3 point. 3, 3 point, z equals 3 plus 5 times 3. So this would be 18. So which one is the largest number? So this one is the largest. So this is the maximum values. 11. So we want to produce 2 products. Okay, product A and product B. So the product A and both products should go through the process on the machine 1 and the machine 2. Okay, so this is the table the problem gives you, product A and product B, and this is the machine 1 and this is the machine 2. So we need 2 hours for product A on machine 1 and 3 hours on machine 2, and 1 hour on machine 1 for product B and 4 hours on machine 2 for product B. So it says the machine 1 is available at most 1,000 hours, and the machine 2 is available for at most 2,500 hours. If the profit let's draw one more column. This is the profit. Profit for product A is $20 per unit. For product B is $25 per unit. We want to set up a linear programming problem to maximize the profit in the following ways. So here we should introduce some variable. So here x would be the number of the product A. We set y to be the number of the product B. So the objective function, we want to maximize what? The profit. So we use z to represent profit, the objective function, profit. So the profit is, each A is 20 and each B is 25. So the total profit is 20 times x plus 25 times y, right? Okay, so what is we want to maximize this objective function. So the next part is the linear program. So we should have some constraint, right? Constraints. So what is the constraints? So the constraint is from the machine 1 and the machine 2. And the machine 1 at most is 1,000 hours. So if x product A and the y product B, so the total hours on the machine 1 would be 2x plus y, right? So 2x plus y would be the total hours on the machine 1 for both products, which should be less than or equal to 1,000, so 1,000. So the machine 2 at most $2,500. So product A 3 hours and each, and product B is 4 hours each. So you have X product A and Y product B. So this is the 3x is the total hours for product A, and plus 4 hours for 4y. 4y is the total hours for product B on machine 2. So the total hour you sum up, so it should not less than or equal to, should exceed, so it's less than or equal to 2,500. We have, of course, we have more, right? Because this is a real problem. So x is the number of the product A and y is the number of the product B. So we also require x is greater than or equal to 0 and y is greater than or equal to 0. So this would be yours.